Hey there, Advanced Math. Welcome back. Just noticed I didn't change the title here. Today we're going to be talking about inequality strategy number 2, which is inverse operation. So let me give you, go ahead and write that down, and when you're all set, unpause, close your math notebook, and move on with me. So, let me remind you of a couple things. First, our first strategy for inequalities was the common sense strategy. And this was one of the problems we did. Mike needs to read for 30 minutes. He's read for 12 minutes so far. How many more minutes does he need to read? And so we kind of said, all right, expression number 1 was, his total amount of minutes, 30. And expression number 2 was what he's done so far. So he's done 12, and we want to know how many more he needs to read. I'll do R for read. And remember, we said with an inequality, he doesn't have to read exactly 30 minutes. It's going to be fine if he reads 31 or 32 or 33. So this can be more than 30 minutes, the amount he reads, or it can be exactly equal to 30 minutes. So this meant this is greater than or it's equal to 30 minutes. And then we used just common sense to figure it out. We said, well, if that's at least 18, then he's going to have 30. 18's fine, 19's fine. So we said 18, he can read more than 18 minutes, or he can read 18 minutes, and that'll be fine. And that was our common sense strategy from yesterday. Back when we were doing this with equations, if he did need to read exactly 30 minutes, 12 equals 12 plus R. Remember, one of our strategies to figure out what R was, even though this one could be done with common sense, one of our strategies was the inverse operation strategy. We said, okay, well, R, 12 is being added to it. So if I do the inverse operation, which is subtract 12, I'll figure out what it is. I'll subtract 12 from this side, and I'll subtract 12 from this side, and I'll get R is equal to 18 minutes. And we're going to use that exact strategy again today. It works the exact same way with inequalities as it does with equations. Check it out. So here we go. So Ryan has $20 to spend on school supplies for the year. He has already picked out a binder that costs $6.92. How much more money can Ryan spend? So this one, when we start to get decimals involved, it's a little bit less of a common sense situation here. So we're going to use the inverse operation strategy here today. So let's see. My first expression is his $20. And my other expression is 692 plus whatever is left. We'll say the M for money, 692 plus however much money he has left. And now keep in mind this, he doesn't have to spend every single cent of the $20. He can spend less than $20 if he wants, or he can spend exactly $20, depending on how it goes. So any value less than or equal to $20 is going to be okay. So I'm going to use a less than or equal to sign for this side. So common sense, it's harder to, it's tough for me to just look at this and decide what it needs to be. So I'm going to, instead of common sense, I'm going to use the inverse operation strategy, just like I would do for an equation. So I'm going to look at this and say, okay, this has 692 being added to the variable. So the inverse operation would be for me to subtract 692. I'm going to take it away. And if I take it away on this side, I also take it away on this side. And this, 692 minus 692, leaves me with 0. So the only thing left on this side is the M. And over here, I've got 20 minus 692. So let me open my calculator. 20 minus 692 is 1308 on this side. So, erase this here. And so I keep the same inequality symbol I had before. The amount of money he spends can be less than or exactly $13.08. Makes sense, because 1308 and 692 would give him those $20. So he can spend exactly that, he can spend any amount less than that. And typically when we do an inequality, even if we use that strategy, we still represent our answer two ways. We want to show our answer this way, and we want to show it on the number line. So we want to say, okay, well, let's see, if this is $13, it's kind of my magic number, right? 13.08 cents is going to be like right next to it. 13.08. And we can go a little higher on this side. 14, 15, 16. A little lower on this side. 12, 11, 10. And remember what we do, we shade in all the areas that meet our condition of being. Did I get the wrong sign there? Do I? No, I'm good. Less than or equal to 1308. So M can be anything, can be over here, can be $9, $8, $7, $6, can be 10, can be 11, can be 12, can be 13, can be 1301, 1302, 1303, 1304, 1305, 6, 7. And when we get to 1308, it is okay if he spends exactly 1308, so I'm going to shade it in too. And so that shows me the amount of money he can spend left is less than or exactly equal to 1308. All right, open your notebook. Let's do one together. So, after buying movie tickets, Durant has $7.85 left to spend on snacks. He would like to buy himself and 3 friends the same snack. What price snack can he afford? So my situation here, I've got 2 expressions. He's got $7.85 to spend, and he needs to buy 4 snacks, himself and 3 friends. So 4 times the price of the snack, S. That all needs to be what? Less than or exactly $7.85. It's fine if he spends it all. Let's assume. And it's fine if he spends less. So 4 times the snack price needs to be less than, this expression needs to be less than or equal to this expression of $7.85. So not obvious to me what to do. This common sense does not quite apply here. So I'm going to do my inverse operation strategy. Inverse op strat. So right now, my variable is being multiplied by 4. So the inverse operation is to divide by 4. So I'm going to divide this side by 4. And I'm going to divide this side by 4. And I'm going to find out that the price of a snack can be 85 divided by 4 is $1.96, it looks like. A little more than $1.96. So let's say $1.96. So he can buy any snack, keep my same inequality sign here. Any snack that is less than or equal to $1.96. Whoop, didn't put S. The price of his snack can be less than or exactly $1.96. And so again, we want to draw that with a number line. Let's just say kind of here's $2. Here's like $1.90. Here's $1.80. Here's $1.70. Here's $2.10. Here's $2.20. That should be enough. And so I need to put in my magic number of 196. Would be a little more than halfway between here, so let's put it there. And I need to shade in the values that are less or equal to, so they're over here. So he can spend $1.60, $1.70, $1.80, $1.90, 1, 2, 3, 4, 5, and $1.96 is okay, it's included, so I'm going to shade it in too. And that shows me the price that he can buy. So this is 2 ways to show the answer. So that's the inverse operation strategy. Exactly the same as it was for equations. Very handy strategy. Please take a look at either of these examples again if you feel like you need to spend some more time with this. Otherwise, we will work on it tomorrow. See you there.